You finally want your AI to answer questions about your stuff, your docs, your wiki, your handbook. But you can't paste a whole handbook into a prompt. It won't fit, and it would cost a fortune. The fix is RAG, Retrieval-Augmented Generation. Today, we build the retrieval half, finding the few passages that actually matter.
Here is the whole idea. Instead of stuffing every document into the prompt, we keep our documents as embeddings, vectors that capture meaning from last episode. When a question comes in, we embed the question too and pull out only the handful of passages whose vectors sit closest to it. Those few relevant chunks are what we will eventually hand to the model. Small, focused, and on topic instead of the entire library. The pipeline is 4 steps, and you already have most of the pieces. 1. Chunk. Split each document into small passages, because a whole document is too big and too blurry to embed well. 2. Embed. Turn every chunk into a vector with one batch call to our gateway. 3. Store. Keep each chunk next to its vector. A plain list is a perfectly good vector store to start with. 4. Retrieve. Embed the question, score every chunk with cosine similarity, and take the top few. Ingest once, then retrieve on every question.
Quick note on the gateway, it hasn't changed at all since the last episode. It already has the embedding endpoint, and that is the only thing our RAG needs from the server. So for today's work, let's just start our gateway. So now in our client, assume here is the all documents our company have, or is our knowledge base, 3 documents, billing, limits, and embeddings. We need 2 helpers, the one that embeds the text, convert the text to vector, and the cosine function that calculates similarity of 2 vector using cosine. And these 2 were from the previous episode. You're familiar. We have a new function, chunk. It splits a document into small passages. We should never cut mid-sentence. And the question is, why chunk at all? Because a whole document is too big and too blurry to embed well. You want each vector to be about one idea, so a question can match the exact passage it needs. And here's the thing that trips people up. It doesn't matter how long the text is, because in our embedding function, we just give the string or list of strings, and the output is always the same, 768 numbers. So the size is fixed by the model, not by the input. So if you give a giant document, it doesn't give you a bigger vector. It gives you a blurrier one, and it averages the meaning that it has. That's exactly why we chunk, and chunking strategy matters. So for our client here, we ingest chunks from every document and save them here with the length, with the original vector and original documents, because we want to reference it after we find the most similar meaning. We want to reference it to the original document. And then we have a retrieve function. Let's run it here before we just do the retrieve to see what we do in embedding. We had 3 documents. From it we got 6 chunks, and each has a 768 dimension vector. Now let's make a query and find the answer using our vector store or vector database. How many requests can I send before I get blocked? So we use the retrieve function, calculate the cosine, and find the best 3 candidates. and print out the document and the text here. So we found the most similar in the meaning for our question here from the limits.md document, and it says every API key is rate limited to 60 requests per minute with around 69% similarity. So,
And that is retrieval. Chunk your docs, embed them, and pull back the passages that match a question by meaning. The R in RAG in about 30 lines. But notice, we never called the language model once. Next episode, we add the G. We hand these chunks to the LLM and have it answer straight from your documents with citations. Real, grounded answers instead of guesses. If this helped, like and subscribe so you don't miss it. The code is in the description. See you there.